Hi, this is Keith Van Wormer, VanTek Consulting. Welcome to the channel. If you are a subscriber, thank you very much for subscribing. If this is your first visit to the channel, we hope you find some useful information here, and if you would consider subscribing, we'd appreciate it. Today's conversation is going to be on these guys, not the specific brand, but the function, and this is called a far end device. So this guy sits at the far end of your cable pair, and it can put various states, testing states, onto the cable pair while you're doing your copper testing. So it can do a short, tip-ring short. It can do a strap to ground, so tip-ring to ground for doing a resistive balance test. So they're pretty handy in helping you do troubleshooting and testing in the copper plant. This guy by Viavi, formerly JDSU, is probably the most prevalent far end device out there. This is a Onyx 580 or a One Expert 580, which is Viavi's latest greatest test meter. Now this guy works with this, and you control it through proprietary tones that are sent from the meter to the far end device. We'll call this Bob. So it sends Bob a tone or a specific set of tones, and it sets a test state on this for some length of time, 60 seconds, whatever. And then after that 60 seconds is over, it releases that back to a normal state. And this is great. The problem is that Bob only works with Viavi or the old HST 3000s it will work with. So again, it's nice, but you have to have this specific meter. So what happens if you're testing and you got this guy? Well, what do? This is an old Dynatel, 3M Dynatel 965 DSP. It used to have a Fed and looks similar to this. It was yellow to match the jazzy color here, but they're hard to find. And if you can find one on eBay, they may not be viable, okay? So what do you do when you have this? What do you do if you have the AMS 965, the more rounded one? What if you have a Greenlee? I believe they're called a Sidekick 2. What if you have an Expo 635? This won't work with those. So there is no, or was no, solution to the far end device issue with these meters. BondingBuddy. So this is a company that has developed an agnostic far end device. So they called me and asked me if I would be interested in looking at this and giving them my opinion on it. And I, of course, said sure. And just to be clear, this is not sponsored by them. I don't get to keep this. This is just a loaner, a demo unit. I'm in no way influenced by any financial aspects. This is just an honest opinion of this device. So that said, this is what they sent me. So this is what I'm assuming comes in, since this is a demo unit, I assume that the retail pack has the green pouch. Within the pouch, we have a little quick reference card, so I'm sure that comes with it. Again, this is a fairly simple little device. You can find more information on this at the BondingBuddy.com. So feel free to jump over there and get your pricing or availability. Nice little pocket here for batteries. It does work on 4 AA batteries. That's its only source of power. Inside, a nice little carrying case to protect it. You get a set of leads, and then you get this guy. So this is the BondingBuddy. This was the hardware. It has a nice rubber jacket on it. There's no buttons on it, nothing to push. So this guy here, to power it up, you use these clip leads. And again, these clip leads are pretty nice. They have a full bed of nails in there, so standard telecom clip leads, so good quality there. They didn't cheap out. So to turn it on, you just merely plug this in. So once you have inserted that connector, you get a green light down here that flashes that tells you that it's on. And then if you want to turn it off as you put it back in your case, you just unplug that and then put it back in the case. If you forget to unplug it and turn it off, not a big deal. It will power off by itself. You just unplug it, plug it back in to get it fired up again. So this guy, what makes it agnostic is that it doesn't use any kind of tones, any frequencies, either multi-frequency or MF or DTMF tones to control this. There's been some other folks that have attempted solutions for these guys and the XFO. And what they've done is they just incorporated an auto dialer function so that you would send it DTMF tones, pound, pound, 243 or something, and that would throw it into a state, so on and so forth. So you would have to set up a dialer in this, send the tones, switch over to your testing application. So these guys, the way that they do their change of states is this is in we're going to call it a normally closed state. So right now, if we listen to this, it sends out tones and gives you indications. So just like a toner would. You can hook a butt setup to this, but it's really recommended to use some kind of wand or something. Because if you have a butt set hooked up to this and you tie it to your meter and you start doing some testing, this guy here is going to influence your measurements. It's going to put some readings on there, and again, that's not going to be good because, we don't know exactly what the copper's doing, okay? This guy's probably the best way to go. So you turn him on. For video, this is just slightly annoying because of the tone. So again, apologies, we'll try and keep it low so that you can hear it. But on pair 1, you can hear that tone, and on pair 2, you can hear kind of a stutter tone. It's pretty cool the way that they do this. Now, in order to change states on this, it doesn't matter what pair you use. You can use the first pair, second pair. So you hook this up at the far end, hook up pair 1, and then at the near end where you have your test set and your wand, what you're going to do is you're going to put a short on the pair. And that short, depending on how long you short the pair for, is going to be the various state that it's going to be in. So example, line 1, you got all your instructions right here. Line 1 beeps 3 times per second. So that's our 3 times per second. Line 2 fast beeps 3 times per second. To open the pairs for 60 seconds, so let's say that we have, right now the pair is going to be shorted. It's going to be tied together. So to open the pair for 60 seconds, we would merely, I'm going to put this over here for a second so you can hear what's going on. We would take this pair and short it for 5 seconds. After the 5 seconds, you can hear that beep has changed. And I believe they call this the uptone. Once that tone has gone off, your pair is now open, all right? So we're completely open. So after 60 seconds, this will go back into its what we'll call the naturally closed state, and you'll hear your identification. One of the things that's actually pretty cool about this unit, if you put Bob on the far end and there's a short on the pair, or a low resistive fault on there, you're not going to see Bob. Okay, Bob obviously can't open it or anything, and of course, if you try and put a toner on there, the toner's going to get shunted. So a lot of times we can't get a tone through there to trace it, and when we work in a terminal, we take our wand and we're trying to figure out where our copper is. We can't find it. It's kind of a pain. This guy here, if you have a short on the line. Okay, so we got a little bit of a cutscene here. I started talking about one of the cool features of the BondingBuddy is when it sees a short or a pair is shorted, it will tone through the short or resistive fault. So it kind of got me thinking of what are the limitations of this. So I got out my official little set of resistors here and got all kinds of different values, and this specific range goes from 390 to 2.4. What I did was we just started experimenting here. So if you have a low resistance short or 0 ohm short, so let's do this one real quick. So we can hear the tone, and if we short this out and don't release it in the 5 seconds or 10 seconds to change the test state, it will go in and start to give us that single beep, okay? And so we're able to kind of get a tone through here. So right now, let me turn this. We can hear it's a pretty strong tone, so that is all the way up, all right? So let's go ahead and turn that down for a second. And as soon as the tone is, or the short's cleared, it goes back into its normal indication. So again, when you're thinking about this, you know, in the telecom, we don't always deal with 0 ohm shorts or low resistance faults, we'll call them. So I took a 1500 ohm resistor and put that in here. So this is 1.5K ohm, and it doesn't do anything. It doesn't change the state. So I want to know how low we had to be in order for the state to, for it to detect it as a what we'll call, for lack of a better term, how strong a short it has to be. So this guy here is the folks that I bought the resistors from cheaped me out and didn't give me the 1.4K, so I had to put in two 680s. So we've got 1360 ohms or so. And at that level, that's about we still get a strong tone there. So somewhere between 1.4K and 1.5K is the break point here. So just understand that when you're doing this, if you have an absolute, if you have a 20K ohm, it's not going to work for you. Just wanted to point that out. Let's go back to the review. Okay, so this is our copper test lab. This is a Greenlee, it's a 1155 FLS. So this is a fault loop simulator. We have a series of rocker switches here. We can do a ground fault, a short, bridge tap, series fault, second bridge tap that we can go into the span on our little test points here. We can put cross battery, power influence, impulse noise, all kinds of cool stuff. We can also do a RFL on this, so a resistive fault locate, so we can put a fault into our primary pair. We have a spare conductor down here for our known good conductor for doing resistive fault locate. So again, we're going to keep this fairly simple. I'm going to hook up the BondingBuddy to this end, and we'll hook it up in a normal state, and then we'll hook up the meter onto this side. This is really big, so I'm going to push this out of the frame, and all we're going to probably see is the bottom of it, but we'll have the meter down here so you can see us. So anyway, let me get this reconfigured, and we'll be right back. So we've got our meter hooked up. We're going to start out with the 580 just because it's a faster meter, so we'll run through the test really quick on this. Okay, so right now we can see that we have voltage on our line, and that voltage is being supplied by the BondingBuddy itself, and that's, we have tone coming out of it, things like this. So in its normal state, again, we can't test any further because we have to clear this voltage. The way we're going to do that is just open up the BondingBuddy. So again, to open this, we're going to do short to pair for 5 seconds. So short, tip, and ring, and I don't have my snips with me, but we're just going to short this. Okay. We can hear our tone now that it's going to change state, so it should go into an open state when it goes quiet. It is now open, so we have 60 seconds to get our test done. So we've got no voltage. We can move to resistance. Our resistance again is 999, so that looks good. Our opens, 1803, 2217, 2215, so there is a little distance on here that's induced on that, but again, not anything that we're going to worry about because this is a constant, and as long as these two numbers, our tip to ground and ring to ground, are correct, we're fine. Let's move over to milliamps. Zeros as we expected. We're testing an open pair, and I'm doing a longitudinal balance test because I want to demonstrate something. So right now I'm using the Viavi fed on the Onyx, and I'm getting a 95 dB of longitudinal balance. What I'm going to do is I'm going to go ahead and lift all the leads off real quick, and we're going to do a start on there, and 89 dB. So again, this device influences your longitudinal balance. And so we got 89, and what did we have on the other one? Let's go back over here, test that, and we got a 94. So there's about 5 dB here. So just remember, when you're testing with this fed, and this isn't a video about this fed, but it's going to add 5 dB. So the reason I'm doing this is the BondingBuddy will also have an influence on your longitudinal balance test. So let's get this guy on here. Tip ring and ground. And then we're going to go ahead and put our open on here. Now what we're going to hear is this is going to go into the open state, but we're going to hear when this goes, we're going to hear, or can hear, a little bit of tone, and what that tone is that's the meter exciting the pair to test the electrical symmetry. So again, we're getting a 90 off this guy, and let's pull him off real quick and do a start, and we're getting an 89. So for intent and purposes, the BondingBuddy actually has less influence on the pair for longitudinal balance than the Viavi fed. Keeping that in mind, what I would do is I would just add 5 dB to our number, so we know that 60 dB is a minimum number for our allowable longitudinal balance. So what I would do is I would say anything here above a 65 is good. Do what you can to get the highest longitudinal balance you can, especially in today's market of VDSL and ADSL 2+ and bonded. It's above 65, you're good. If it's in a 64, 65 range, I would open the pair completely and do the test that way and see what that says. And so we would get our 91. Again, not a big deal on this. So let's go ahead and give this a shot with the 965. Okay, we've got the 965 all hooked up on the open pair, so we don't have anything on the far end. I have it zoomed in pretty tight so that we can see the screen here. So again, we're just going to run this through. We have 0 volts on our, this is tip and ring. Then we're going to go over to our tip to ground and our ring to ground, nothing there. We'll go over to our ohms. Okay, so our next step would be milliamps, but we don't expect to see any current on there because we have no voltage. So we're just going to step right over to our opens. And on our tip to ground, we have 1525. On our ring to ground, we got 1531, 1526 to 1531. And again, on our tip to ring, we have 1708. So again, these numbers are a little different because this is Cat 5, different capacitive than value than air core. But we're looking at the tip to ground, ring to ground, and verifying that both conductors are absolutely equal length and one's not longer than the other capacitively. All right, and basically that's it. We would go in here, we could look for other things, but that's our base testing on this. So again, let's go back and we'll hook up our tip to ring. We'll throw that same series fault in here, and we know that it's there. So we're just going to jump straight back to our resistive test to see how this would work. So we're going to short this again together for 10 seconds. All right, we've completed our short. Now we've got our warning tone, so let's go back over into our ohms and get the meter ready. So we're expecting 160 some odd ohms, so 166 here. Then we're going to go to our tip to ground. Our tip to ground is going to give us 455, and our ring to ground should be 510, roughly, 515. So there's our 60 ohm series in there. So again, This works great on legacy meters. It works great on modern meters. You just got some little manipulation to do, which is fairly simple. The time that you spend on this, hooking this up and doing it is less than driving back and forth and strapping and unstrapping and all that fun stuff. So again, this guy here, pretty simple to use, pretty straightforward. Seems to be good build quality. The people up there at Pine River Innovations are just an awesome group of folks. I had some questions on this and talked with their engineer that designed this. Very responsive. So again, I think that this is it's a valuable tool to use in the field. I'm a firm believer in using firing devices. Give these guys a call. Check out their website. Again, this is not sponsored. I don't get anything from it. I do have to send this back. Other than that, if you have any questions, comments, leave them in the comment section below. Like, subscribe, which is always appreciated when you subscribe to the channel. Ring the bell, all that wonderful fun stuff. Keep in mind that I'm not going to have this with me. I'm sending this back this week, so I'm not going to have this in my possession. So if you do have something specific on this, I'll answer what questions I can. But again, it's pretty simple. So most of the questions that you would have would probably pertain to the actual copper testing. Always glad to help you with that. Give us a holler. Again, always happy to answer questions. If you want to see more videos like this, or you have other questions on copper or fiber testing, GPON testing, Ethernet testing, feel free. Leave us a comment. Let us know what you want to see, and we'll try and get a video out for you. Until next time, I hope everybody's safe, and we'll see you on the next video. Thanks for watching.